Hi, Geometry. This is Unit 1, Lesson 11. It's on reflections, and I'm on page 74 of your workbook. The spacing on my page is different than your workbook. This activity, this part of our activity, will actually be on your page 75. So let's get started with this problem. In order to do this activity, you'll need your compass and you'll need a straight edge. And I'm going to use two ideas that we've discussed in a previous lesson. Just last week, when we did lesson 10, we were looking at the fact that reflections, let's take a look at this blue S and its reflection, the green C. When I reflect something over a line of reflection, in this case line M, the point is reflected along a line that's perpendicular to the point of reflection. So we're going to use that today. We're going to create these perpendicular lines to our line of reflection. And in order to create them, we're going to use a construction that you're familiar with from lesson 6. Construction number 7 is a perpendicular line with a point not on the line. So what I'm going to be given in my problem is my point that's not on my line of reflection. So let's take a look at this particular problem. It says Kieran started to reflect triangle CDE over line M. So far he knows that the image of D is D prime, so that means that D prime came second, and the image of E is E prime. It says annotate Kieran's diagram to show how we reflected point D. So draw a line between D and D prime with your pen or with your pencil. This right here is that perpendicular line that we were talking about from our lesson 10. And so D is this distance away from our line of reflection. So let's go find that distance. We don't want to measure it with a ruler or anything. We want to use our compass. It's a straight edge, so we don't need rulers for anything. So I'm going to measure my distance. And if I come over and put this pointer on my line of reflection, I can see that D prime is that exact same distance on the other side of the line of reflection along this perpendicular line. So let's take a look at number 2. It says use a straight edge and compass moves to determine the location of C prime. Then lightly shade the triangle in. I'm going to find C prime, it's somewhere over here, in the same way that we found D prime. So I need to do two things. I need to first construct a perpendicular line. This perpendicular line will go through C and will be perpendicular to line M. So that's construction number 7. Let's do that first. So you can go back and look in your notes if you need to, but our step 1 was to create this circle. I'm just going to do part of the arc. That the radius can be anything you want, but it has to go past my line of reflection. So my pencil can't be here, my pencil can't be here, it can't be closer to C. When my pointer's on C, my pencil has to be somewhere on the other side of M. So now I'm going to use that to create a circle, or this part of the circle is what I needed. I needed to see where my arc was going to intersect my line of reflection M. Those two purple points are the points I'm going to use to create my perpendicular line. I'm going to measure the distance between my 2 points, and putting my pointer on one of the points, I'm going to arc that distance up. And you can create a whole circle if you want, but I really just need to arc that distance above and arc that distance below my line. Let's put my pointer on the other intersection point. I'm going to arc that distance above, and I'm going to arc that distance below. And that gives me 2 points where it intersected. And really, my 2 points should be in line better than they are. My lead on my compass is getting rather dull, and I think that's creating some human error on my part. But really, your points do not have to line up on top of each other, but they should, whether those two are close together or whether they're farther apart. It all depends on your compass setting, but really they should be in line with each other. And so you'll notice mine are a little not in line. I'm going to draw my perpendicular line. This is my line that's perpendicular to my line of reflection. I put a perpendicular symbol there. And so a lot of times kids think this is C prime, and I think it's going to be for me. It's a coincidence, but it's because I set my compass to the exact distance between my two intersection points when I did these two arcs. So if you set your compass to a different distance, then your C prime might be somewhere else. But I'm going to measure anyways, because that's my step 2. I measure the distance that C is from my line of reflection, and then I flip it over and I mark it on the other side. And you'll see that basically it lines up right where this point is. That is my C prime. So that is a coincidence. It doesn't have to line up with where your original arc was. Again, it depends on the distance you set your compass to when you did this arc and this arc on this side. Your arcs could intersect above or below where that point's going to end up. So let's connect my C prime to D prime, and let's connect C prime to E prime, and then D prime to E prime. Lightly shaded in like the directions asked. And if you needed to verify that you did this correctly, like if you're working on a quiz or something of that nature, you can always take patty paper and trace the original figure and where the line of reflection is. Very carefully fold it exactly where your line of reflection is, and your original shape that you outlined should line up on top of your new reflection. So that's how you can double check your work to make sure that you did it correctly. So it says write a set of instructions on how to reflect any point P. So granted, we had C across line L and we had line M when we did it. So I'm going to change my vocabulary a little bit. But my first step was to construct a perpendicular line to, in this case, it was line L through P. And that was construction number 7 in your notes. And then finally, the second one was to measure the distance from P in this case, C when I did it, to line M and mark the distance on the other side. And that would be your P prime. So let's take a look at Alina's drawing. On Alina's drawing, she has a problem here, and I can tell that just from looking at it. What do you think that might be? Maybe the fact that they're not the exact same size. Remember, a reflection is a rigid transformation, meaning it shouldn't change the size of my object. So I know that C prime must not be in the right place. So it says to explain to Alina why C prime is not in the right spot. You could do it one of two ways. One way is to recreate what we did up here, and you could show her that C prime's really somewhere else. I want to show you the second way, since we just did that right above. A second way is to use points E and D, because if you've got 2 points of your triangle, you can use them to find your third point. And this is actually a nice shortcut for when we get to lesson 13. So I use point D and I find out how far C is from it. And then I put my pointer on D prime and I mark that distance. Everything on that gray arc is the same distance as D is to C. So I know C prime should be on that gray arc. I don't know where yet. So let's measure the distance from E to C. And now I'm going to take my pointer and put it on E prime. And I'm going to mark that as well. That tells me exactly where C prime should be, because this point is the correct distance away from D, because it's on my first arc, as it is away from E, because it was also on the second arc. It was the intersection of those two. So this is really where C prime needed to be in order to create my triangle. So let's take a look at the summary. I want to point out a few things. First of all, when we have a line of reflection, line L, and we have point A, our step one is to construct a line perpendicular to L through A. So that's what's done right here. This is my perpendicular line. So this is my step one. Step one was to construct my perpendicular line to L. So now this is when you measure the distance A is to the line. So let's do that, you guys. Let's measure, it's almost the same distance I need. So let's measure the distance between A and the line, and let's go mark it on the other side. So I know that my A prime is right here, because my distances will be the same on either side of the line. So this right here was my step two. It's when I measured my distance. You can see those steps on the reverse page if you needed to. So this is an example of my reflection across line L. So now I want to switch gears a little bit and talk about something that's coming up. I want to talk about a rotation. So the actual same movement can be done in a rotation. So I'm going to call this O for the origin. And take a look at the same A and A prime I have right above. If you look at this, this is a half a circle or 180-degree rotation, whether you go clockwise or counterclockwise, around the origin. So I could also get to the same place if I did a 180-degree rotation, careful how you word it here, around, you got to tell me the center, around point O. And usually you need direction, counterclockwise or clockwise, but since it's 180 degrees, it would be the same either way. And that would get you to the exact same image of A prime. Thank you very much.